In this lesson, we'll explore big idea number 1 and talk about the rate of chemical reactions and describing them quantitatively. This takes us to learning target number 5. By the end of this lesson, you should be able to experimentally determine the rate law of a reaction and explain its significance. Being able to predict how fast a reaction will go before performing it is an important tool to have. Unlike controlling reactant temperature, changing reactant concentration has different effects depending on the specific reaction. How a single reactant influences the rate is known as its order. We will discuss 3 different cases in this course. Zero-order reactants. The reaction rate is independent of the concentration of a reactant. This means that the reaction will go at the same speed no matter what reaction concentration. First-order reactants. There is a proportional increase observed in the reaction concentration and the reaction rate. For example, when you triple the concentration of a reactant, the rate triples. Second-order reactants. The reaction rate increases by the square of the concentration increase. For example, when you triple the concentration of a reactant, the rate increases by a factor of 9, which would be 3 squared. How all the reactants influence the rate is quantitatively described in a mathematical equation known as a rate law. Once found for a particular reaction, a rate law can be used to calculate how fast a reaction will go at any set of concentrations, or what concentrations you need to use for your reaction to go at a particular speed. Since there is usually a direct relationship between the reactant concentration and rate, so when concentration increases, so does rate, we can write the following proportionality statement. If I use the general equation A plus B produces products, then the rate will vary directly with the reactants. We write that like this. Now, because each reactant will have its own influence, we have these things called rate exponents. They're represented by m and n. Now, in order to change this proportionality statement into a math equation, we need to introduce a constant that fixes the relationship for each reaction in real life. This constant is necessary because it's not always a complete direct relationship. The rate constant K indicates the inherent speed of the reaction. The larger the K is, the faster the reaction. The value of K changes based on what temperature the reaction is performed at. So the temperature is always reported, but you never really have to do anything with it. The rate exponents m and n represent the order of each individual reactant. They must be determined experimentally, and they are independent of the temperature. The sum of the rate exponents is known as the overall reaction order, and its value is interpreted the same way as individual reactant orders. Here are some examples. Given the following rate laws, describe the influence each reactant has on the rate, and then describe the overall order of the reaction. So for example A, reactant A has the exponent 1. That means it's a first order reactant. Means that we'll have a proportional increase. If I double the concentration of A, the rate will also double. The same is true for reactant B. It has an exponent 1, so it's also first order. Now the overall order of this reactant is the sum of the two rate exponents. 1 plus 1 gives me 2. that means overall I have a second order reaction. So if I increase both reactants, then the rate will increase by the square. So for example, if I double both concentrations of the reactants, then my rate will speed up by 4 times. Pause the video and have a look at example B. Here's the answer for example B. Because for reactant A, I have a rate exponent of 0, then it's a 0-order reactant. That means no matter how I change the concentration of reactant A, the rate will stay exactly the same. For B, it's a first order. That means I'll have proportional increase. Overall, my reaction order is first order. That means if I double the concentrations of the reactants, then my rate will double.